Hello and welcome to the TelecomTV Summit on the Green Network. I'm Guy Daniels, Director of Content, and coming up now is our discussion on sustainable challenges and initiatives in mobile networks. Radio access networks are becoming more extensive with greater densification, leading to an overall increase in energy consumption. So which parts of the RAN can be made more efficient? What can be done in the core? And what innovations are underway to address these issues? Well, let's find out what our guests think, and I am delighted to introduce Laurent Leboucher, who is SVP Orange Innovation Networks and board member of the NGMN, Yogesh Malik, who is EVP and CTIO for Tele2 and also an NGMN board member, Jane Rygaard, who is head of dedicated wireless networks and edge clouds at Nokia, and Philip Laidler, who is partner and managing director consulting with STL Partners. Hello everyone, very good to see you all. Thanks so much for taking part in this discussion. Now, when it comes to mobile networks, where does the RAN rank in terms of telecoms, energy consumption and carbon emissions? Is it really the least green aspect of our networks? Phil, I wonder if I could maybe start you off, because I know you've been doing a lot of research in green networks. So, can you clarify this one? Is the RAN a big contributor or negative contributor towards the green network?
Well, I think the RAN consumes a lot of energy. And for most mobile networks, 70% plus of the energy that goes into running the networks is consumed within the RAN. So that's the starting point. That doesn't necessarily make it the biggest culprit, but it's certainly one of the bigger challenges. And so that would be my answer in terms of its importance and overall stakes for reducing emissions.
Thanks, Phil. Jane, last time we spoke, we were talking about the energy of the RAN and the radio components. It's a significant amount, isn't it? A significant element of energy consumption by telcos.
It is, and also if we look at when in the RAN lifetime is it spent, it is in use, right? So when I come as a radio vendor, what can I do in the production parts beforehand? What can I do? But if I look at the overall science-based targets that I look at from a Nokia perspective, well, then it's in the consumption of the RAN being live that this is where we see that the biggest problem such as lies. And that's why also we need to look at what happens. How can we reduce the energy consumption of the radio when it is in use? When can we turn things off? Where can we be better? Where can we do the right things to reduce this, not only in terms of rising energy prices, but also because we want to make sure we do the right things, right? So from a sustainability target part, this is definitely where we need to put a focus on.
Yeah, thanks, Jane. Well, let me expand this question out a bit, and Yogesh, let me come to you. We're looking at the RAN here. Are there certain parts of the RAN that perhaps could be made more efficient?
First of all, thank you. Thank you for having me. We at Tele2, I think it's good to take a step back, believe very, very critical in sustainability. We are actually carbon neutral today, and we know that RAN consumes the most energy. For us, now the focus is on reducing consumption and retiring technologies which we are not using. To share network is critical as well. So I think that is the way we are encouraging a sharing mindset and go by design deep into the fundamentals and make sure that we address that using algorithms and functions as well, that we can reduce power consumption.
Thank you, Yogesh. And I'm going to ask Laurent the same question. Are there aspects of the RAN that we are looking at and investigating to make them more efficient, energy efficient?
Sure. Thank you. Thank you for having me. So as Phil and Yogesh said, the RAN represents roughly 70%, or we say between 70 and 80% of the energy which is consumed by mobile network. Today, we believe that power amplifiers are responsible of approximately 60% of the RAN energy consumption, and therefore there is a lot of improvement to be done here. It was already the case in the past. If we look back at previous technologies, 2G, 3G, 4G, and we saw that there was a lot of improvements which were made, but it took a long time. It took 10 years. And today, with when you look at massive MIMO antennas and so new evolution of the RAN, the energy efficiency of the power amplifiers can really be enhanced, and it will be enhanced. It will be improved. We know that. So that's why we believe that operators need to work very closely and also share the vision with the microelectronic companies to help them anticipate the needs based on the usage and the requirements. We also believe that radio sites, because they are multi-technology, they have to, it's a mix of 2G, 3G, 4G, and 5G, which are active at the same time. And because of that, if we develop solutions to maintain active only the technologies which are used at a given time, and then dynamically switch off based on the usage, it will bring a lot of savings. As it was said also before, sharing RAN networks between mobile network operators can reduce quite a lot the consumption. And we have feedback from our colleagues in Orange in Poland, and we see that we can achieve 30% reduction. There are also some improvement that could be done on the technical sides where the equipment sits. For instance, we expect strong benefits from the new liquid cooling, immersive cooling, and also how we can use direct current, 400 voltage direct current, and metering. So I put an emphasis on metering because if you really want to make progress, you need an excellent metering. And then you can also add to that intelligent control, and then you can get quite interesting savings.
Thank you, Laurent, for those facts. Yogesh, I'll come to you in a second, but let me go to Jane first for some comments, and then we'll come back to Yogesh.
I was just actually thinking when Laurent was speaking that one of the key aspects of this is that we can improve the technology, and we have improved it so much over the last years, right? In both in terms of hardware, in terms of software, new chipsets, and everything else we're using in the radio. But there's still a key part if we look at where the energy consumption is, because of course that requires that the new technology is in use in the network. And if we look at the networks today and the amount of network equipment that is still catering for 2G, for 3G, for now we will soon have to say as well as for 4G, right? It is something we need to take into account when we look at where do we consume the energy. That it's not enough that we actually just renew it from a technology point of view, but it has to be renewed in the network. Otherwise, we'll just continue to use the old equipment. So it's just a thought, because I think that everything that Laurent said is definitely on the right side of where we need to look at the technology in use for it.
Absolutely. Thank you, Jane. Yogesh, let me come across to you for some additional comments.
Now, it's extremely critical, the discussion we are having, because as much as we are introducing new technologies, we have to take responsibility to take out older, to sunset in a customer-oriented manner. And the algorithms which can be done today, what Laurent was mentioning, for example, power amplifier, when to switch off and on, when the data is being transmitted, how to sunset, and then the devil is always in the details. So continuous improvement mindset is critical. And I think we shouldn't shy away. Data volumes are going to keep growing. So unless and until we embrace that strategy, refurbish, make sure that we densify, and make sure that we can share and be very open to learn from each other to reduce and focus on consumption, I think that is what we really should be working every single day. So if you're a radio engineer, you should be motivated to learn from each other on how to reduce further, how to make sure that we can address that consumption systematically in a sustainable manner. So that is what I wanted to share.
Great, thanks for that. And we've heard some great ideas there. Laurent, let me come back to you because there is a lot to cover off in this one particular topic about just making the RAN more efficient. So Laurent, let me come back to you.
Yes, because we were talking about efficiency, and I think it's not just about reducing consumption. It's also about how we can improve the CO2 impact through the use of reusable energy. And I think that also we can clearly use what we call solar on grid. So typically installing solar panels at the RAN sites. And this is clearly something that we're doing and that we will extend in the future.
Thank you, Laurent. Phil, we've heard a lot of ideas and a lot of technologies there. Something that's getting a lot of traction at the moment, one area is Open RAN, of course. And does Open RAN play a role here? Could it play a role to be a positive contributor to energy and emissions reduction?
Well, it's a slightly controversial topic, if I'm honest, Guy, because currently a lot of Open RAN deployments appear to be consuming more energy. And that's to do with the nature of the chipset and the hardware and the way it's being deployed. And I know the industry is working very hard to get that down and to improve the performance of the Open RAN deployments. And that's a big focus at the moment with that community. So there's a lot of work to be done there. And there's a lot of hope that both with that advancement in chipset and the software, but also with the introduction of better orchestration through things like the RIC, that Open RAN will be able to introduce more and more improvements in its performance. And it is certainly a big area, and there's a big hope that it can bring that. But right now, there's a long way to go, I think the industry would agree. It's an area that we need to see some big improvements on.
Great. Well, thanks for that, Phil. As you say, there's a lot of uncertainty and slightly controversial aspects of Open RAN in this particular field that we need to understand better. Jane, what's your thoughts on this?
So I was actually just triggered by Phil said RIC, right? So we have with the near real time RIC, we have an opportunity to also to be able to host AI/ML closer to the radios themselves, which again, are we able to optimize the way we use the software, optimize the whole radio performance, so that you also not only optimize the whole network just for the sake of the end user throughputs and the normal radio KPIs, right? But really start optimizing it also from an energy perspective. And there, I do think that what we do have with the RIG deployments within the O-RAN community, that we do get this opportunity of more AI/ML in different segments. So what can we do very close to inside the radio software itself? What can we do on the near real-time RIG? And then what can we do on the full orchestration layer more centrally in the network? So for me, it's a key component that we need to take into account when we talk about this.
Yeah, thanks, Jane. And let's hope that developers get behind the two RIGs that we're talking about here, and we see some progress. Well, that's the RAN. What about the core network? Laurent, perhaps I could start by asking you, is there anything we can do in the core network to help with energy efficiencies?
Yes, of course. So first of all, we need to start by understanding that the core represents between 8 and 10% of the total energy which is consumed by the network. Nevertheless, there are many topics which are currently being studied to achieve more efficient core networks on the fixed part. And if I take some examples, on the IP side, we are planning to deploy, for instance, in Orange, 400 gigabits per second new routers with 400 direct current, voltage direct current, VDC, which are much more efficient. And they have a higher energy efficiency. And we believe that we will save a lot of consumption here. Regarding also IP, the new architecture layering IP over WDM seems also to be very promising. the integration of 400 gigabits modules within the routers can be also interesting convergence strategy, because it provides not only capex savings, roughly 30% compared to the legacy, but it is also it brings a lower consumption of energy, roughly we believe 40%. So it's very significant, and this is something that we are studying and that we consider to deploy.
Yogesh, is there anything you can add for how we can make the core network perhaps more energy efficient?
Yeah, so while percentage-wise, core may not be representing a lot, but there, the depth is much, much deeper. It goes from applications to servers to routers, as we discussed. And I think it very much depends on cross-sharing and learning, because now we have professional data center providers as well in the same territories, and how we can learn from energy cooling, how we can learn from knowing our own applications and consumptions of those applications, of routing, and how we can take that out. So the path we are on in Tele2 is to know that architecture and to systematically go one after another to make sure that we are routing traffic properly to consume absolutely right amount, and then the servers which are old to be refurbished or to be renovated, and the applications which are not in use to be retired so that they are not in idle state consuming power also. Beyond that, we have to make sure, though we are in a carbon neutral, again, focus on consumption. So that is the way we are doing it in Tele2.
Great. Thanks, Yogesh, for that update. Well, unless there's any other comments about the core itself, the core specifically, then why don't we move on? Laurent.
I would like to concur with what Yogesh just said. I think cooling systems, the new cooling systems, are very important. And in Orange, we believe that we need to invest on free cooling, liquid cooling, and immersive cooling, which are quite promising. And we've dedicated a lab in Lannion in Brittany to study the impact of those new cooling techniques.
Thanks, Laurent. And Jane, let's come across to you for some additional comments.
Yeah, that was. I think the liquid cooling is a very, very good example. Which, of course, one of the things that we have been looking at also from a Nokia perspective in this connection is that when we move, and we now talk about that as a core is as centralized as it has been, but we can definitely see that with some of the core functions moving further out in the network, this idea that how do we establish edge clouds and data centers further out, that also needs to have this wide approach. So what we've seen is that some of the initial liquid cooling discussions has assumed that the data centers are in one place and very big. And we definitely would like to take it one step further and saying, can we use the same techniques and therefore talk about liquid cooling also for edge data centers? And then, of course, we have our programs also for the classic radios where we do the same. But I think that the combination of exactly saying, can we save on air conditioning and therefore also on some of the consumptions that we see in the mobile network, that's a very, very critical part of it.
Interesting. Yeah, thanks, Jane. Phil, you wanted to comment on this one as well.
Yeah, I think both on Jane and Laurent's point, a key thing that is happening is both core network functions and the edge network functions are increasingly being run or expected to move to these mini data centers, these edge data centers. And that puts absolutely a bigger burden on the monitoring that Laurent referred to, on the designing of these spaces, which, if we're not careful, they will be less efficient than the bigger data centers and the places where they have significant cooling and power. So there is a real need for figuring out how we build these small footprint edge data centers to operate extremely efficiently, and how we monitor them very closely and optimize those and optimize that passive infrastructure as well as the active infrastructure that's running within them.
Yeah, thanks, Phil. We've been hearing all week about how much energy the passive infrastructure actually consumes, which is quite staggering at times. Yogesh, you wanted to come back in.
Yes, no, it's absolutely critical what Phil mentioned, Jane and Laurent, because for me, again, we have to look into 5 years from now, if we are going to have private networks in more places, enterprise data hosting, we have to start thinking core to be much, much more agile and much, much more kind of expandable yet replicable in many different ways. So that is the thing I wanted to add and share.
Thanks, Yogesh, and thanks everyone for your comments on that particular question. Well, let me move on and look at 5G. Does 5G have inherently efficient technologies baked into it? I mean, what is the net effect of 5G rollout? You know, do green savings as a result of 5G technologies make up for perhaps the increase in densification? And we're going to be rolling 5G out all this decade. Jane, perhaps I could just get some initial thoughts of you as to just, you know, how green is 5G?
Well, there is the obvious answer that we've talked about since 5G, the first 3GPP specs came, right? That how much energy does it cost to transfer a bit? And there, of course, 5G from that perspective is better. Simply the way that the whole layers and the protocols used are being more efficient. But then coming back to the starting point from Laurent, right? What does a 5G network today? What is it built out? How have we modernized the network in order to do 5G? And I think that's actually with the growing data consumption, because you can say that the fact that we are more efficient per bit, if we transferred a lot more bit in these networks, then that saving is sort of like gone from that perspective. But then if we modernize the networks at the same time, that's really where we're going to see that the biggest part of the savings is. We get new technology in while the technology itself is better at transporting the bits at a lower energy cost.
Great, thanks, Jane. Well, there's more to talk about 5G, and next month I think we'll be talking a lot more about 5G. February is the month, February, March, the time of 5G. So let's move on to a final question for today then. And where do you all think we'll see the most innovations in the coming years that will help achieve our ambitions of the green mobile networks? And, you know, what innovations are already underway that give you the most faith, or that you're perhaps the most interested in? Laurent, perhaps I could start by asking you, you know, where do you see the most exciting innovations in this area?
I think if you look at 5G, what we call advanced sleep modes will have a quite significant impact and are quite innovative. They can potentially reduce by more than 30% the energy which is consumed by antennas, massive MIMO antennas, to typically 32TR configurations. And we are what we are seeing today in the market, we are seeing 5G antennas which are combining massive MIMO and those advanced sleep modes features, and they can really achieve extremely interesting consumption reductions. And it will improve in the future. They already have very significantly improved during the past few years, so I'm quite confident that here we'll see a lot of new innovations at the antenna level, especially at the antenna level.
Thank you, Laurent. Phil, what about you? What are the innovations that you're perhaps keeping an eye on, or we might see the most benefit from?
Well, I think, as we've heard today, there probably isn't one innovation. It's all of the things we've heard. It's the underlying hardware, both at the radio level, the amplifier level, but also at the chipset level. It's the advanced functionality and the functions themselves and the orchestration of those functions that is coming in. But yeah, there is a big challenge because traffic volumes are going up and up and up, and our ambition is to reduce both the energy and the carbon within the energy that goes into powering that ever-increasing volume. And I think the real innovation will be in how we run and operate our networks, will be in the industry's own ability to innovate and introduce more openness, but more innovation. And the RIC is one thing that I think we'll be talking a lot about this year. And I think there's a lot of hope that the RICs together and all the predecessors to, and that evolution to a RIC will help to drive a lot more innovation, particularly around energy efficiency and performance. I think also it's not just technical. I think we as an industry can do more to educate our customers about efficiency. We can work more. For example, the companies that do speed testing across networks, they actually encourage operators to leave their networks on maximum all day long in order to obtain the highest possible scores and downloads and uploads. I think we as an industry need to be smarter in how we measure performance and work together so that we can turn down our networks at 3 a.m. and not be penalized in terms of our performance. So the innovation is there absolutely with the technology, but we also need to innovate how we educate and work with our customers around energy efficiency.
All right, interesting points there, Phil. Thanks very much. Laurent.
Yes, in addition to what you said, I believe there is also some very innovative features that could come in the future about how the network can feel the customers, feel the traffic, and based on the traffic knowledge, understand, for instance, if there is a low traffic condition, then decide to migrate services from 5G to 4G, because for a long time, we will have 5G and 4G at the same time. So deciding in a very clever way, based on the traffic, how we can shut down some antennas and power amplifiers, and then decide to switch them back when it's when the traffic is there again. I think is also some interesting features that should come.
Thanks, Laurent. Well, let's just keep with this thread for a second. And Phil, I'm going to go straight back to you now.
Yeah, I agree. Yeah, and again, I think it's not just about being able to do that, but it's about doing that without being penalized, as it were, by the market. It's great to be able to take down your 5G off-peak time and just rely on 4G, but you don't want to then be told you've got poor coverage or your 5G is not performing or the download speeds are not high. So I think there is a two-way process here, because we can optimize, but we're telling the market today the same thing as the car manufacturer was saying in the 1970s. It's all about power and speed and fast. Whereas today, the car manufacturers are talking about energy efficiency, performance. They're all about the lowest possible emission that my car can produce. We need to start educating our market to start thinking about the services in the same way too.
That would be a significant change, wouldn't it, if we can pull that one off? Let's hope so. Jane, let me bring you into this final question. We talked about a lot in the past 30 minutes or so. There's a lot of technologies we covered there, but are there any particular innovations you've got your eye on that seem most promising?
But it's always a good thing about coming as number 3 in these kind of questions, right? Because a lot of things have already been said. But I think if I had to sum it up, I would definitely say that yes, we need to look at the chipset development and how we use the compute that is available the best possible way, both for the radio and the baseband on the radio side, right? And then also for the cloud technology, given that. Then I probably want to sum up Phil's operational parts into AI ML, because it doesn't help if we can't automate these things. If we have to run manual things, then it's never going to happen, right? If we want to sort things down at the right time, or we want to optimize depending on traffic, it needs to happen immediately when it is, which means we need to get into much more, and we will already now, right? What is the software way of controlling this with AI ML? And then I think, and Laurent, you touched on it earlier, right? In what are the parts and how quickly is things like liquid cooling, green energy, how quickly is it moving and how quickly can we adapt to these parts? Because of course, if we use renewable energy, we also need to understand what is the impact of the surges of using it, right? It's not constant. If you have, I love your solar panels. I unfortunately live in a country where then the radio network would not be running half of the year because there's no sun. So we need to come to a way of coping with these kind of technologies within our networks as well. And then I think the last part, which is actually amazingly true, came from you, Phil, is also about the applications. We've for so long time, also from an application point of view, basically telling people it's okay to transmit all data at the same time. So we're always online, we're always doing, but maybe also from an app development point of view, and that's bringing back to my edge cloud topic. If you look at the amount of application developers that is looking at having apps lying on the edge, can we save some transport cost of the bits to going into wherever the first part of the pre-processing of the data needs to happen? So can we also, in this terminology of a green network, think about how we can reduce the amount of data that needs to be transported within the networks at the same time as we're doing what we need to do on the technology level across the chip development, the AI, ML, and the renewable energy.
Thank you very much, Jane. And Yogesh, we've heard so much that there's a lot of promise in this area. There's a lot of innovations we're talking about, but are there any particular you think that will come good in the next few years and really help us to make a big difference?
Yeah, I think this is an area to watch and not to be complacent. I would say site design is going to be critical. How we design sites, both edge sites, transmission sites, how do we design sites? So I think that's one area to continuously watch for. Second is to promote a responsible mindset, which means we need to know our applications. We need to know what we want to contribute to our customers, and that supply chain innovation, so that the more and more innovation comes there and automation, I think it will make everything better. So I think we have to be open to learn, open to share, and keep an eye open on these things as we move forward.
Thank you, Yogesh. And Laurent, I'm just going to come back to you for a final comment, because I know you wanted to comment on one of the answers we heard earlier.
Yes, I think I'd like to come back on the technology itself. And at the beginning of this session, we talked about power amplifiers. And I think we also expect much better efficiency on new semiconductor technologies. Typically, moving to what is called gallium nitride, we should really expect significant energy efficiency improvement. Maybe something like 60% for using those new semiconductors in the coming years.
Thank you, Laurent, for that last point. And with that, we must draw our discussion to a close. Thank you all very much for participating and sharing your views. It's been absolutely enlightening. And if you are watching this on day 2 of our TelecomTV Summit on the Green Network, then don't forget to send us your questions and we'll try and answer them in our live after-show program later today. And please, if you have yet to do so, then take part in our online poll, which you can find below this video player window right next to the Q&A app. For now, though, thank you for watching and goodbye.